thank you guys for joining us today. So I'm Mackenzie. I'm joining us from QUT today. I'm a final year medical engineering student. So I'm just here to help facilitate and run the Zoom part of the webinar today, and give a little bit of an introduction to Sen before he carries off the presentation. So yeah, this is another one of the Meet the Researchers 2021 webinar series, and we're going to be hearing about fired bricks using clay mixture from Mr. Sen Wang. But before we get into the presentation, QUT acknowledges the First Nations owners of the land from which we're joining this event today. We pay respect to their elders, laws, customs, and creation spirits. QUT acknowledges the important role Aboriginal and Torres Strait Islander people play within the higher education community. QUT acknowledges the Turrbal and Yagara as the First Nation owners of the land where QUT now stands. So a little bit of an introduction to Sen as well before we start. So Sen Wang is currently a PhD candidate with an interest in researching clay mineral and building material. He is part of the research team of Associate Professor Yunfei Chi, who'll be giving a bit more information about as well. And Associate Professor Yunfei is a dedicated expert in minerals, clay minerals, structure and properties, development of their functionality, and investigating application of these new mineral-based materials. So Associate Professor Yunfei's team looks to apply their research in practical and environmentally conscious solutions. So yes, Sen will share more about the team, current research, and insight into how to make better bricks. So yeah, at the end of his presentation as well, it'll be a really awesome opportunity to ask some questions about, this space in science and in material design, to find the potential in all these raw materials that we find around us. So yes, now introducing Sen.
Okay.
I'll give you remote control of the presentation as well. There you go.
Okay. Thanks, Mackenzie. Thanks for the introduction about Yunfei and me. And good morning, guys. As what Mackenzie said, I'm the final year PhD candidate at QUT, and my research interest is clay mineral and building material. I cannot control it.
Oh, I think it's working now. Perfect.
Yeah, sorry.
Sometimes it's got a bit of a lag.
It's okay. And Associate Professor Yunfei Xi is my supervisor at QUT. He's also the program leader of Building and People at QUT. His research areas mainly focus on the application of minerals and clay minerals for environmental remediation, building materials, and energy storage. And Yunfei is not available today, but I'm sure he will also join us during the internship in the lab. So as my group mainly do research on clays, here I would like to talk about what is clay at first. So if we look at clay from a geological point of view, clays are minerals formed by geological actions, which is different weathering conditions, and clays have obvious plasticity. And clays are more like an emphasis on particle size. They are not some special kind of minerals. And for a long time, the definition of clay is not very clear because the researchers from different backgrounds, they define clays with different particle size. As you can see here in geology and so on, they define clays with a particle size less than 4 microns. However, in pedology and colloid science, they define clays as some particles less than 2 microns, 1 microns. So this phenomenon always confuses a lot of people who do not work in clay area. So
Sorry, I was just letting someone else into the group.
So this is why in 1995, the Joint Nomenclature Committees of CMS, they give the latest definition of the clays and clay minerals. So clay is a natural occurring material composed of fine-grade minerals, and they will become plastic when they contact with the water and harden when dried and fired. Clay mineral is some phyllosilicate minerals and minerals which can give plasticity to clay and make clay become hard when drying and firing. So in a word, clay is some special groups, some special minerals. Oh, sorry, clay mineral is some special groups in clay. Sorry, guys. And clays and clay minerals are very, very important resource on our Earth, and probably the most widely distributed resources. If we look at the image here, we can see the distribution of several typical clay minerals. We can find them in a lot of areas all over the world. They exist in topsoil and subsoil. And in the United States, production of clays was estimated to be 26 million tons and valued at 1.8 billion in 2019. So clay and clay minerals are very, very important resource. So where does clay come from? If we look at the rock circle, we can see there are three different kinds of rocks in nature: igneous rocks, sedimentary rocks, and metamorphic rocks. Clays mainly exist in sedimentary rocks. They just look like this in nature. There are some weathering products from different kinds of rocks. And if we use the scanning electron microscope to observe the morphology of clay minerals in a very high magnification, we can see different clay minerals. They have different structures. Some is like a fibrous structure, others are tubular and plate structure. If we look at the clay minerals in a nanoscale or angstrom scale, we can even divide clay minerals into two different types. The first is 2-to-1 type, which is composed of two tetrahedral with one octahedral in the middle, just like a sandwich structure. And the other type is a 1-to-1 type. It contains one tetrahedral and one octahedral, like collinite. And the use of clay and clay minerals, many of you guys may know that we can use clays to make very gorgeous porcelains, some terracotta warriors. However, clays can also be used in other aspects in our life, like they can be added to the paint, they can be used for the car bumper, cosmetics, and even medicine. If we focus on the clays for building materials, we can see human beings began to use clay to make brick in very, very ancient times, probably like 7,000 years ago. And now bricks are still very popular product because of many benefits. The modern brick making process is more advanced and automated if we compare to the ancient bricks made by hand, because now people use the factories, they use many machines which can give consistent properties to the bricks we obtained. But however, we can still find some failures in the bricks we obtained. These pictures are provided by our local industrial partners, which means these problems are just happening now. And to dispose these bad products will cost them like millions of dollars every year, which we should avoid these problems. So what's the reason behind these problems? It is because the clays to make a brick, their clays are very highly heterogeneous materials. Even in the same quarry, we can see different kinds of clays on top, some yellow color glaze, on bottom, some brown colors. Even some clays look very similar. After we fire them at different temperatures, they can behave very differently, not only include the colors, but also their mechanical strengths, their thermal insulation properties. So different clays, different bricks. If we want to always get some good brick, we need to have a fully understanding on the raw clays we used. And at PUT, we can use many very modern instruments to test the components in our raw clays. We can know what kind of minerals are inside, what kind of elements are inside, and also we can test the thermal behaviors of our clays. Like we can know the shrinkage and expansion of our clay bars. And this property is also related to some cracking problems in the real brick body. And also we can even simulate the brick making process in our laboratory. We can make very cute brick buttons and to see what kind of things is happening during the firing process to make a brick and how different things or different minerals combine together in a brick. After we have got our product, which is bricks, we can investigate their properties, like their strengths, their colors, some insulation properties. So by this way, we can build a relationship between the raw clays we used, the final properties of the bricks we have obtained. And this is what I'm doing during my PhD study. And it's like a collaboration between university and industry. So my advice for you guys at this period is you'd better have a plan for your future career. No matter you want to work in scientific area or some industry area. And if you plan to become a scientist, do not just study science, because you will find that different disciplines just cross together and always curious to everything in your life. Okay, thanks for your attention.
Thank you so much, Sen.